objectives for our what we call polar coordinates for and how we can compare it to what we call our Cartesian plane, our XY axis, right? So first of all, in our Desmos, that's our polar coordinates, right? So if we go to our graph settings, we can click on the polar graph, right? Or polar coordinates for such. Check it out as in terms of radians, and we would see this one as what? Each of the circles in there has its corresponding radius. For example, that one is the radius r equals 4 and the angle given as well. For example, if we say polar coordinates say follows. 5 and 4 pi over 3. So where is that one? 5 and 4 pi over 3. So with that being said, that means that the radius is 5. Okay. So that means we're considering this particular radius with is 5. So that one in there. Get it? Okay. With an angle of 4 pi over 3, all right? So where's that 4/3 pi? As we may see in here, 4/3 pi is on the third quadrant, right? So as we may notice, then that will be the following in here. So if you see the 4 pi over 3, which is this point, right? So that means that is your angle, 4/3 pi, right? So that means this point is the point now, which is what? 4 pi over 3. How are you guys? Now, what is that in terms of its xy coordinates, right? If we go to our xy coordinates like such, we're gonna click in here, go to the xy coordinates, right? And see what value that will be. Get it? Okay, and so later we're gonna see that this one, this r theta, will be a quadrant 3 value equivalent to what? Well, it's x and y coordinates are as follows. The x will be r, which is 5, cosine of the angle, 4 pi over 3, right? And the y, it's the sine, right? That's the horizontal or vertical component of that angle, 4/3 pi. So with that being said, what is this? What's 5 cosine 4 pi over 3, guys? What's cosine 4/3 pi? Calculator, 4/3 pi, what do you think that will be? Negative square root of 3 over 2, right? Get it? Oh, cosine, sorry, negative 1/2. Sorry, negative 1/2, right? Thank you. Right. And this one will be what? 5, and sine 4 pi over 3 is the negative square root of 3 over 2, right? Got it? Is that what you said, Kamari, a while ago, right? Negative 1/2 and negative square root of 3 over 2. Anyway, so that will be it, right? So let's see. Let's locate. Is that the correct point that we have been looking into a while ago, right? So let's put it in here. The first x-axis is where? Negative 5 over 2. There we go. Comma. What's the y-axis? Negative 5 square root of 3 all over 2, right? Now, can we see that the graph that we got is the same? Let's see in here, right? Oh, okay. So it hits the right spot that we have just done a while ago, right? So that basically is our goal for today, okay? And what is that? Here it is. For our goal for today. Let's read this one in here. Reagan, go ahead. Yeah. Plot points.
Plot points using polar coordinates.
Correct. Yeah. Convert
from polar coordinates to rectangular coordinates. Convert from rectangular coordinates to polar coordinates. Transform equations between polar and rectangular forms. Identify and graph polar equations by converting to rectangular equations.
Thank you. All right. So basically, that's what we're gonna do, and this is our summary for such. All right. So here's what we noticed. Your polar or our polar coordinates is as follows: r theta, right? Radius is basically the what? It's the hypotenuse between the x and the y coordinates, right? So that means what? Square root of x squared plus y squared, that is our r. Okay? And our theta, once again, is the what? The angle between the y and the x coordinate. So y is sine, x is cosine, so sine over cosine is tangent, right? So that angle, tangent inverse of that will be your angle. But again, that is the reference angle still. So what do? The absolute value of y over x, tangent inverse of that is the reference angle. Now, we have to know what quadrant it is based from the signs, plus or minuses, to know whether we what? Just copy it, subtract it from pi, right? Subtract it 2 pi, or subtract it from 2 pi. So depending on the quadrant. Get it? So please do review our quadrants as well, okay? But anyway, let's see now what now will be the corresponding x and y, or what we call rectangular or Cartesian coordinates. The x is always r cosine theta, right? Whatever your radius is. And the y is always going to be your r sine theta. Are we good? Right, so that basically is our goal for such. So let's compute for this one first, right? You are given a polar form, 6 and negative pi over 4. That's your r and theta. What do you think will be your rectangular coordinates for such? Again, this is number 8 on your practice set, okay? So what do? What is the x value, guys? What's the x coordinate? R cosine theta, right? So what's your r? 6. Very good, right? So that's your r, and this is your theta, right? So that's it. Your x coordinate in here is what? 6 cosine of what? Negative pi over 4. Get it? And your y, however, will be what? The sine equivalent of that. So that's what? 6 times what? Sine of negative pi over 4. Okay, so guys. So if we need to get the exact value for such, first of all, where is cosine negative pi over 4? What quadrant is it? Very good, quadrant 4, right? Honestly, it's a coterminal angle, but basically it's quadrant 4 with reference angle pi over 4, right? So what do you think is this? Cosine negative pi over 4 on your calculators? Exact value.
Negative square root of 2 over 2. Oh wait, which one?
Cosine. Cosine is what?
Positive.
Positive. Very good, right? So this is positive square root of 2 over 2 times 6, all right? Do not forget that. And in here, that is what? 6 times what is now sine of negative pi over 4? Sine of negative pi over 4 in quadrant 4? Negative, right? Square root of 2 over 2. And that's it. That will be our answer for such, right? So this will now will be what? 6 over 2, that will be what? 3 square root of 2. And the other one is negative 3 square root of 2. Are we good, guys? Now let's verify. Again, let's verify if we got the answer right. Okay, so let's go to our Desmos and put in the values for x and y in here. What did it say? 3 square root of 2, right? Comma, negative 3 square root of 2. Okay, so that is it. That is our value, right? Okay, now let's see. Let's go to our polar coordinates and see what value that one is. So as you may notice in here, okay, I went now to my polar coordinates or polar form. Let's see, what's the radius in there? 6. Got it? So your radius is 6. And now what's the angle for such? So if we can verify in here, right? So from here to, oops, okay. So if we imagine a circle, right? Okay, polar, right? That considers that one, then the radius is what?
45? Oh, no,
6, right? Okay. However, what's the angle? Well, as you may notice in here, from this initial side to the terminal side in here, clockwise rotation is negative, right? And how much is that? This is basically this is 7 pi over 4 in quadrant 4, right? But its coterminal angle is what? Negative pi over 4 degrees from here. Got it, guys? Oh, well, radians. Got it? Thank you. Questions? Right. And again, you can verify that one in degrees as well if you want to. But typically, for these cases, we are considering the radians, right? But again, if you want to verify that one in degrees, you can just click on the degrees in here, and you can see that that is, how much of an angle is it? 315 degrees. Are we good, guys? Or negative 45 degrees, if you want to convert it into the degree measure. Are we good? Right. Once again, our goal in there is that, okay? If you are given r and theta, then that means your x is r cosine theta, and your y is also r sine theta. Are we good? Right. Now, let's do the reverse, right? Let's read in here number 13. Chase, go ahead.
Compare 3, negative 5 to the polar.
Okay. So this is the x and the y now, okay? Thank you. So this is the x and the y. What now is the r and the theta for such? So again, this is the reverse of what we did in here, okay? So since this is r, what is the formula for r again? That one, right? Square root of the sum of the squares of these two. Get it? So that's it, right? So your r is square root of what? 3 squared plus negative 5 squared. Are we good, guys? Right. Oh, what's that gonna be? What's this gonna be, guys?
36.
So 3 squared is 9, and this is 25. Okay. Square root, right? Here we go. And what's that? 34. 4. Honestly, there's no there's no perfect square factor for square root of 34. So we'll just leave it as it is, right? Because honestly, 34, it can be written as 17 times 2, right? Which are both prime anyways, prime numbers. So there's no perfect square factor, right? So we'll just leave it as it is for r, right? What is theta, right? So your angle in here will be as follows. Tangent inverse of what? Absolute value, by the way, absolute value of, what's that again? Negative 5 thirds. Are we good, guys? Right? So tangent inverse of the absolute value between the y and the x, right? The ratio. Okay. So since it's absolute value, you just leave it as what? Tangent inverse of 5 thirds, right? So let's put it in a calculator. What's that gonna be? Let's say, put it in here, okay? So here it is. Put it in such, okay? Okay, here we go. Tangent inverse. Where's the tangent inverse? Click on the functions. Click on tangent inverse, all right? Absolute value. You can click on the absolute value as well if you want to, all right? And then plug in the following. What is that again? 5 thirds, right? Is it 5 thirds? 5 or negative 5 over 3. Okay, so again, don't forget the absolute value. Okay, we want it to be in radians, so make sure you click on the radians in here, and we saw the value, right? And what value did we see? 1.03 radians. Get it? Okay, so we can put in here that that is what? 1.03 radians. Approximately. Again, this is just the what? This is the reference angle, right? So if that is the reference angle, what do we do? Well, we need to know first what quadrant is it. If it's positive on the x and negative on the y, what type of quadrant is this? Where is it? Quadrant 4, right? Positive x, negative y. So if this is in quadrant 4, what do we do with this then? That's the reference angle, right? What should we do? Quadrant 4. Okay, verify. If it's in quadrant 4, theta in here is just equal to reference angle, right? We good? For quadrant 1. For quadrant 2, what's that again? Your theta is what? Call it pi minus, right? Reference angle. Get it? Okay, whatever your reference angle is, pi minus that, okay? Which is 3.14. For quadrant 3, what's our angle? Pi plus whatever your reference angle is. Get it? Okay. And the last one for quadrant 4, which is what we're going to use in here, what do we do? Whatever your angle is, what do you do? 2 pi minus the reference angle. We good? Right. So with that being said, what do we put in here? 1.03, since this is quadrant 4, 2 pi minus 1.0. Are we good, guys? Right? Oh, what's that going to be? 2 pi minus 1.03. Okay, let's put it in here. What do we have? 2 pi minus 1.03. And we got what? 5.25 radians. Get it, guys? Right, so let's put that one in here. That's you. This is, what's that again? 5.25 radians, right? 5 and quarter radians. Okay. Well, lastly, let us verify. Let us verify if we actually got that answer right. Are we good? Right, let's see. Okay, what is the angle again? 3, negative 5. Good. Okay, so that's your 3, negative 5. Your radius, it says to be how much? Square root of 34, right? So let's see. Let's put in there. R is equal to square root of 34. Okay. Oops. Let me just go ahead and erase these in here. Just letting you see that actually the radius, which is R of square root of 34, actually hits that 3, negative 5. Get it? Okay. And your angle theta is how much again? 5.25, right? So I'm going to put in here. See the 0? 0 theta to what? What did we say? 5.25, okay? Now, as you may notice in here, your radius is square root of 34, right? What's our angle? It says 5.25 radians, right? Again, make sure it's in radians. If you put it in here, your angle is from 0, that's the initial side, to external side, which in here is approximately 5 1/4. As you may notice, it actually hits that point, 3, negative 5. Did you get it, guys, right? So the good thing in here is we can verify if we're actually getting in the answer right by looking into that. Are we good? Questions, guys? So it's important in here to like switch from rectangular, or what we call Cartesian coordinate, to polar and actually verify, are we actually getting the answers right just from the plotting of the points? Get it? Questions, guys? Okay, and the last one in here, well, second to the last, right? So let's read number 18. What do we do with this number 18? Okay, Chloe, go ahead, read that one here. Y equals
4x squared. Convert to polar.
Okay, let's convert this one to polar equation, right? So what do we do in here? So when you say convert to polar equation, we need to transform x and y, in this case x squared actually, into what? R and theta. Okay, so how do we do that? What's the first step? So y, once again, is what? According to the formula, y is what? R sine theta, right? So we're gonna convert this one into R sine theta, right? So this is what? This y, let's call it red, right? This y can be written as R sine theta, right? Is equal to 4. Now this x squared in here, okay? What do we do with that? Well, x is what? X is r cosine theta, right? So I'm going to put in here. X is r cosine theta. And what do we do with this? Square it. Are we good, guys? Right, so let's put that one in there. Step number 1, right? X is equal to what? R cos theta. Y is equal to r sine theta. Next thing to do is the following, right? Step number 2. Solve for r, right? As you may notice, your polar equation should always have r on the left side of the equation, right? So with that being said, what do we do to isolate that r? Have that r on the left side of the equation. Let's put it in here as such. Oops. So this will be what? R sine theta, and this will be what? 4 r squared cosine squared theta. Get it? Okay. So we just want the r on one side of the equation. So how do we do that, guys? What do we do? Well, first of all, you just want r, right? But this has r squared, right? So I'm gonna do is what? Divide r both sides, right? Mr. Deal, how do you know that we can actually divide both sides by r? Well, since r is non-zero anyways, right? So we can divide both sides by r, right? So with that being said, what's gonna happen here? These two will cancel out, hence we got what? Sine theta is equal to what? 4r cosine squared theta. We good, guys? Right? So we already get the r, but we just want that r on one side of the equation, right? So what do we do? In short, if you want to isolate that r, what should I do with this 4 and cosine squared theta?
Divide it.
Divide, very good. Both sides by that, right? Again, you just want the r anyways, right? So, very good, that is correct. Since you just want that r, then divide both sides in here by what? 4 cosine squared theta. Okay, so what's going to happen here? The cosine squared theta cancel out, the 4 is going to cancel out, hence you got your r, right? Is equal to what? What is this then? 4. Okay, so this is what I'm going to do in here. We can basically do this, the following in here, right? Okay, here. Okay, let's read our step number 3 in here, all right? Paula, go ahead, please.
Step number what?
3, right? The last step, right?
Express theta
Theta.
in terms of sine and or cosine.
Thank you, right? So as you may notice in here, if we divide both sides by 4 cosine squared theta, then we can just write the left side as follows, right? That r is equal to what? Sine theta all over 4 cosine squared theta, right? Now, here's the deal. In some cases, you can express cosine squared theta as 1 minus sine squared theta and simplify it further if you can. However, typically in here, you don't need to express them in terms of other trigonometric functions like tangent, secant, cosecant, or cotangent anymore, right? So as long as all of your terms are either in sine theta, cosine theta, or both, then you are fine with that. Are we good, guys? Are we good? All right. Questions with that one? Right. So we're gonna stop with that one for now, and please do copy first. All right. Thank you. Thank you, Chair.